fellow programmers, welcome back once more to this course for drives. So for this topic, we're going to be looking into some parameters that are advanced. Okay? Well, quote unquote. Because honestly, the parameters that you guys are entering, aside from the ones that I already mentioned, are through specific applications. And they're basically by your logic. Now, you may say, oh, sir, or Rodrigo, there's many parameters that we haven't seen yet. Yes, there's hundreds of parameters, but are we really going to use all of them? I ask you. Now, you ask yourselves also that question. Are you really using all the parameters? Out of those 500 or 1,000 or 2,000 parameters, are you really going to use them all? Not really. Sometimes, in very specific occasions, very specific times, you may be able to use a couple more that I already showed you. But these are very rare occasions. Okay, so therefore, I'm going to tell you what those parameters are that I consider are special. Okay? So it goes farther beyond the parameters that I think are more important, which is auto-tuning, and they're not mentioned in any videos or any details on the field. So that's why it's a very important and strong tool. If you want an advanced parameter, it's all about auto-tuning or self-tuning, and for when are we going to use this? Okay? Now, what is really an advanced parameter, or which ones are advanced? So I'm going to base myself out of my PowerFlex 525, which I will be leaving you on the resource part. But also, mostly for communications that I'm going to leave this for you here. Whenever you're programming with your PLC, that's where I'm going to leave it for you. Now, I'm also going to review this, and we're going to check how we got this, okay? All right. Now, we have here parameter groups, so let's analyze them. Which advanced parameters can we get from here? Basic display. These are our most basic parameters that show us that we cannot overwrite or write even for these parameters, because it says here frequency output or output frequency. I can't write anything about this. It's only for viewing. This is all about simple monitoring. Commanded frequency. These are our outputs frequencies. Is the current part? This is the commanded part. At which velocity or frequency do I want my motor? And here, this one is what's the real frequency? Actually, what's the frequency that my drive is getting? So we have the same thing. Output voltage for our DC bus, sorry. And we can check here our parameter for our power saved. Now, this is where we're getting our control source from. Is it from the keyboard or is it from the external part? And this is where we can actually view the outputs for our RPMs, our velocity, our potency. This is merely visual. Our code for fault number 1, which one is it displaying? Here, this is actually the accumulation for the kilowatts per hour. How much are we saving for accumulation cost. And you guys are going to decide if you want to use these or not. So drive temperature, this is an important parameter, okay? Just so that we're able to monitor. And if we have any questions, if, for example, we have a sort of sensorless control, and if we see, or if we want to monitor our torque, and remember that our torque is our current. Also, if there's a lot of current that's being commanded, the temperature can increase. Okay, so this is for monitoring. Now, what else do we have here? This is also very basic on the language part. For data input for our motor. Our auto tune, a torque mode. This is a parameter for auto tune. It's this one. And mostly let's look for this. I want to check this. Our control part. Now, where is this? Where is this? As an advanced parameter, I suggest that you guys take a look at the control part. What type of control? It seems as if it's this one. So let me look for this. So the control part, let me look for this here. So sensor. Sensorless. Okay, here we go. So our control part, this is all of our control modes, which this drive can support. But we need our parameter. Our control method, or volts hertz. And this is here it is. This is an important parameter, guys. We have here our control mode, volts hertz, sensorless. And here, related to Rockwell automatic, they said that they want to use number 2 to economize. So therefore, they're going to start watching where they can choose this option to save up on energy. Okay, so the control part for permanent magnets, for the vector part, and their control, the one that they suggest, is one without RNA, which is a direct torque, which is what we had previously seen. So this is the torque mode, okay? Now, what type of application are we going to use? This is an important parameter, guys. If you guys have an easy application, leave it as such, okay? Generally, this is where we get our volts hertz part, but here, by default, we already have our number 1, which is sensorless, where it's decided by precision, torque, and low velocity, okay? So this is set by default. But if we wish to have more velocity, and you guys see that there's not really a big increase for velocity, and there's a minimum load, then change it to volts hertz, okay? Now, this is an advanced and important parameter. Now, what else can we see here? We can also see our terminal part. It's actually this one, our power flex, but we actually see this on our Yaskawa drive. So we actually know, thanks to our emulator, that we can control velocity because it's actually non-active here, but we can control we can control its forward and backward control. Okay. And how's the drive here? So move it forward, move it back, start, stop. We already configured our input, but oh, here we go. It was for S6. I didn't know what parameter we were moving it for. Because this is a velocity reference. So multi-speed. We already know the most common thing about our digital inputs. And in theory, we know that any type of entry or any type of input, we're going to look for this as multi-function so any entry, any input that I wish to assign, let's say number 4. If I want to assign number 4, in this case, parameter H104, which means that I'm going to be affecting this input. And from this, I'm going to choose our option, because here we have our fault reset option, which means that whatever I have connected here is going to be a regularly open button. And at the moment when we deactivate, it should clear out that alarm or that warning notice. However, if I decide to change it, for example, for a jog, it should be number 12. Now let's see if I activate number 4. Well, apparently it doesn't do a thing. It only cleans out the alarm. It's a reset button. Now we can't see this, but because there's no active reset. So if I change it as 12, what's it going to do now? It already changed to our function number 12, which means it's going to jog forward. According to what? According to our assigned frequency for our D117 parameter. Which, okay, this is the jog reference, but what does the jog really do? Well, we basically activate it, and it's going to move our drive forward, just as long as it is keeping my input active, or I keep my input active, my button. Okay, so if I keep my button pressed, it's going to start my engine. If I stop pressing it, it's going to stop. Now, what are these for? What is this for? This is to run maintenance tests or have the motor move at a pretty slow pace or even a stronger or faster pace. Okay? Now, regarding which rhythm, it's going to listen to whatever reference that I have assigned here for my D117. Let's see if this is true. So that's D117. Let's see here. 16, 17. At 6 hertz. Okay? So if I press this, it's going to move along to 6 hertz. But the conversion is at 680 hertz. So the button is pressed here. It's like I'm continuing press. But if I remove this, it's going to stop. Now, what's going to happen if I increase our frequency? Let's say by 36 hertz. Let's see if this is faster, though. Well, it did increase. Okay. And here, actually, this is already at 36 hertz. So that's what we do when we jog this. Now, what did I do? The entry that or the input that I wanted to assign, we assigned our parameter. We assigned whatever value to our parameter. In this case, it was for 12 to H1-04. So that entry put was for this specific point. Now, this is pretty easy, guys. Now, what else can we check in our parameters? Now, as you start noticing and you start seeing this, our parameters, we're actually going to use them as we require, according to our project, according to whatever our application asks us to do, our customer. Here, for example, our communication part is basically all about configuration. What type? for our node, just in case we have an RS485, or if we wish to configure our IP, we just add it, and we add these parameters. If we want to add a subnetwork, then we modify these parameters. It says configuration number 1, we have our octet for my sub-configuration number 2. And so on. Now, what else? Our terminal blocks, we already saw this. Our analog part, if we wish to have a limit, whether it's high or low, for an upper and lower limit, then it's already set at 10 volts. But what are these 10 volts going to represent? For example, what else? We have here a multi-function part. Let's see this. We already have this here. For example, we have our PID part. Now you may say, well, PID is a little bit more complex. I'm going to tell you guys something. Here, it works perfectly well, our PID control, but I would not recommend this unless you want a basic PID, an easy PID. So our drive is a miniature controller, but it's not a controller. If you wish to control a PID, if you want a temperature PID, then I basically, I think it's a little bit more useful, a temperature controller, because these are specifically for temperature. So these are already internally ready to run PIDs and add any manual gains, etc. But not here. Our drives use a PID, and this is actually their task, their function. But to be honest, this is the primary idea is their motor. We don't want to mess around with our PID. Now for that, you either get a temperature controller or a processor, or even easier though, a PLC. Okay, so if we wish to be exact, I would not recommend PID on your drive. I wouldn't recommend this. I've installed this, I've set it up, I've adjusted their gains manually, but guess what? It's not as efficient as a PLC PID or a temperature controller, a thermometer. Okay? So you guys may say, well, here for my inputs, I can use integral value for my PID. Yes, because it's a digital input anyways. And if I want to add an integral on hold, we can also do that. But again, I ask you guys, how many much more applications does a PID need for a drive? It's very uncommon, very rare. Okay, if you guys need it, then we have our part so that we can configure our PID. Okay, let's see here, PID control. It's going to ask us for on the control part and on our integral part and our derivative part. It's just going to ask us for all of these characteristics. And it's going to say, well, if you wish to control with your PID, with a PID, your velocity, then the sensor that you need is velocity reader. Okay? Now, where though? Well, this is where we have our analog input, which don't actually work as a potency meter, which is already established. Okay? Now we're going to look for our simulator. And on our potency meter part, we're going to connect this, and it's already assigned. It's already on our voltage positive for our A common. But if we wish to use a PID, we need to tell our drive that that's going to be our PID control. And this is where it says, how are you going to add this configuration? and it tells us our steps. Now, this is what tells us. If we wish to add a control velocity, then add a velocity reader. Okay, so apply the sensor. If you need a fluid control, then you need a fluid sensor. If you want thermometer, okay, then in this case, you need a temperature sensor. So then you guys are going to have to identify its application for which sensor to connect. And from there, you have to run your own calculations, okay? Now, we can tune a PID, for example, depending on the set point. And here is where it says how to assign this and how to adjust it. But again, I would not recommend using a PID if it's something a little bit more advanced. That's why it's better to use a PLC. Okay, this is our more advanced use. So if you wish for a control aside from the tuning, the independent tuning for the PID, then what you can do is you can enter the ranges manually. The proportional gains are integral time. And this, how are you going to get these data? As I had previously mentioned, through software, or if you want to do it by hand, the calculation, that's okay to do so. But there's already very efficient ways to get our PIDs. Now, this is our most advanced issues and topics on our drives. And from here, it's all going to depend on your application, whatever you wish to modify. However, I have to tell you guys, there's also a way to control your PID with your drive. Is it as efficient? Not to my liking, but if you want to make it efficient, go ahead, guys. You can also affect the acceleration and deceleration times. So here, that's why this is pretty important, because these are basically our set point values and their scalement. Now, if we wanted hertz or percentage or RPMs, or if we wish to define these units, to set these units. Do we want chickens? Do we want eggs? It's all going to depend on our scaling. Okay, so here for our upper limit scale, we have here our input scale, because we have many things here. And that would basically be everything. Now, what else can we see here? We can also see here, for example, we have an advanced display, which is a little bit more data filled to deploy on our PID. Here, for example, with our PowerFlex 525. And here it's telling us advanced programming, but this is something, for example, we have jog frequency. We have our presets here for our frequency, again. Acceleration time if we have 3 or 4. Or if we wish to take a little bit more time. And also depending on where we're going to get these times. Time 2, time 3, time 4. Also for our PID part, which is basically our more complex part. But here are gains if we wish to adjust them manually. So more than our auto tuning, if that didn't work and you wanted to use a sensorless control, if you wished or wanted to adjust it with that control, but it needs to be more efficient, then all you need to do is add the manual gains and individual gains. Okay? All right, now, encoder. Encoder type. What are we going to use an encoder for? This is to get my motor position, or the position on something. And now regarding our position that I have, am I going to run certain movement or a certain velocity? Okay, so this is already for a closed loop, what I was telling you about, which is something a little bit more sensorless. Now, for smaller applications, remember, if you want position, you can get an encoder that, remember, it's a device which helps us get position on something, which is something maybe a little bit more rotational, which is my motor. But if I don't need much precision, then I'm going to use my sensor list function. So scaling my encoder pulses, its accounts, and how many accounts can my encoder take. So this is basically all of it. So that's why I was saying that it has many parameters, but we're not going to use all of them. But these are our most advanced parameters regarding on what happens. Now, if you guys go to the parameter, you're going to be able to verify where it matches. But if the motor is for permanent magnets, this is basically all of the advanced issues. So diagnostics and failure, we already saw this. And what else here? Well, our groups, and it's basically all of it. Yeah, if you notice, this is our drive if we already know how its structure works and how it's handled through our parameters, faults, alarms, etc. Now, how do you guys feel? Do you guys think you're fully prepared to go to the real world? Guys, you need to be very secure about how to configure them. And I'm telling you this the nicest way possible. If you don't know much about drives, you need to look for a way to connect one drive. So raise your hand. That's why I was saying you need to be a little bit more confident. Okay? But you also need to be very careful and mind the electricity. I mean, you shouldn't be scared of electricity, but be respectful of electricity. So do things very aware. So what is the rookie mistake that most of us do at the moment when we connect the drive? It comes to a point where probably we are so trusting, and wherever for example here, that we're confident about something, but I've seen this happen many times on the field. If the engineer is already confident and they know how to install the drive and they know when and how to do everything, then they control these outputs. This output is for our motor and this one is for our drive. So they feed the motor output. Okay? So if we do this, then automatically our drive is going to stop. It's going to burn out, sorry. So you need to be very careful. And sometimes I know that my drive, after this course, you're going to make this much quicker and with a lot more experience. Okay, so this is excellent. Now, you need to be very careful. And also, this is our most common error and mistakes. And I've met other people make fun of other engineers because they connect the feed part incorrectly. But guess what? This also happens for you guys. It also happens that they make fun because they get burnt bad. So all you need to do is need to be very careful. These are my recommendations. These are the advanced list parameters that I can indicate according to my experience. Do not overcomplicate anything. Don't memorize everything. Because if you don't memorize the 100 parameter, if you memorize the 100 parameter list, you're only going to get to use 2 or 3. So I wouldn't recommend doing this. If you wish, you can analyze a little bit your parameters. Don't memorize them, but read them so you can have them in mind. It is no use that you memorize them. If you're going to memorize something, memorize the methodology or more important things that we're going to be using on the field. Okay? Now, this is basically it, guys. I hope this was a lot of use for you. If you have in mind any parameter that you guys can consider or any questions from work or the university, tell me, guys. We can all solve this together. So, if you see a parameter that is very important and you can't and you can't find the solution, then we can launch a video related to that specific parameter and run that update in our same course. So having said this, big hug, guys. Thank you very much for your time, and I'll see you guys in our next class.